Hello everybody, today we're going to talk about arcs. Before we get into talking about arcs, let's talk about some specifics about circles. First of all, in this circle that you see here, it has a center point which we call point C. The center of the circle helps you to name the circle. So the center of our circle here is C. So if we wanted to name the circle, the way we would name the circle is we would draw a miniature circle symbol like so, and then use the capital letter that's representing the point in the center of the circle. The other information that we know about a circle is what we call the central angle. Now the central angle is just that. It is an angle and it goes to the center of the circle. A central angle is specifically a special type of angle whose vertex is at the center of the circle. So an example of an angle that we have, you can see I highlighted it there in orange, is angle ACB. The other thing that we're going to be talking about today, most of what this lesson is about arcs. By definition, an arc is a portion of the circumference. Okay, now the portion of the circumference is going to have a relationship to angle measurement. So before I get into the different types of arcs that we have, let's talk a little bit more about the specifics of a circle. In a circle, two things that we need to remember is that a circle is 360 degrees around the circle. And remember, if you go halfway around the circle, it's going to be 180 degrees if you go halfway. 180 degrees would be considered a semicircle. Okay, so when we are talking about the different types of arcs, there are two kinds of arcs. There is a minor arc and there is a major arc. The names make sense because minor arcs are smaller than major arcs. A minor arc is an arc that has an angle measure of less than 180 degrees. A major arc is the opposite of that. It's an angle measurement, an arc with an angle measurement of 180 degrees, larger than 180 degrees. A semicircle is exactly 180 degrees, right? So when we're naming an arc, anytime that we name an arc, there are two ways to name an arc depending on if it's a minor arc or a major arc. Now a minor arc is an arc that goes from endpoint B to endpoint B, but it's the shorter way around the circle. Okay, so that means that it is AB. So the way we name this is it's going to use the two letters AB, the endpoints of the arc, and then you're going to put a little arc symbol over top of it. That represents arc AB. Now you might be thinking that arc AB would go from this endpoint in the longer way around to that same endpoint B. We don't call the major arc or that longer way around AB because we would get confused as to are we talking about the shorter way around or the longer way around. So to distinguish between whether we're naming an arc that is less than 180 degrees or bigger than 180 degrees is we use more letters to name our major arc. Now our major arc is the longer way around. It goes from A through D to B. So I'm going to use those three letters in that order to name this arc. So those are the two arcs that we have. Okay. Now there are two ways to measure an arc. So there's two ways to measure an arc. those two ways are to measure the angle of the arc, and there's also the length of the arc. Both are found differently, but both can be done. Okay, when they are asking you to find the measure of the arc, the angle measure of the arc, they will designate it with an M in front and then the name of the angle, like so. Or they will tell you in the directions, as you can see in this problem here, they will tell you, find the measure of the arc. So if you see that, you know that you're trying to find the angle measure of the arc. Now, the angle measure of the arc relates directly to the central angle. The angle measure of the arc is equal to the measure of its central angle. And I'll explain what that means. So if we, for example, in part A, in part A, that we're using this picture over here, it says RT is a diameter, tells us our circle is circle P because P is the center point. In this problem, they are asking us to find the measure of arc RS. So we're finding the measure from point R in the shorter distance to point S. Okay, so that's the measurement that we're finding. So you can see that from R to S, we have this angle right here. We have this angle right here. They tell us that that central angle is 110 degrees. So if the measure of angle RPS equals 110 degrees, which it is, then we know that the minor arc that it's related to, so then we know that the measure of arc RS is also equal to 110 degrees. No work involved. That is your final answer. So for the second problem here, RTS, let me erase my work there, we are dealing with a major arc. And the reason I know I'm dealing with a major arc is because it's 3 letters. So starting at R, going through T to S. So we're going to find the measure of arc RTS. Now we know that that's going to be the measurement of this central angle here. So if this portion here is 110 degrees, and we know the whole way around is 360, the way that we would get our answer is we would do 360 minus that other part that's not included, which is 110. So the answer to our problem is that the measure of arc RTS is 250 degrees. Don't forget your degree symbol when dealing with the angle arc measure of the angle. Okay? All right, so the next thing that we are going to talk about is we're going to talk about arc length. Now, arc length, I want you to think of arc length as the distance along the curve. Okay, and the way we measure it is we measure it in units like inches or feet or meters, kilometers, just to name a few, right? Okay, so there is a formula for this, but the difference here is that imagine if you were running around here, you would want to know how far you've run. And we can't set a ruler along a curved length. So in order to know it, you have to sort of imagine that you're taking that AB, right, and you're stretching it, right? Imagine you were stretching it. That's how it would go if you stretched it out, right? So, and then you'd be able to measure it using a ruler. But We're not able to do that. So what we're going to do is we are going to use the equation for the arc length of whatever arc they're talking about. Let's say we're talking about arc AB. So the arc length of AB, for example, okay, is going to be equal to 2 pi r times the fraction, the measure of the arc. So notice it's measure of the arc. Let me write that again. By noticing that it's measure of the arc, we know that this is going to be a degree measurement like we talked about up above. And then we're going to divide that by 360 degrees. Okay? So the way that we are going to do this is we will plug in the information that we know and we will solve for the information that we don't know. Anytime you have an unknown value, you are welcome to just use x as your variable. But this is the formula we're going to be working on or working with in the next two examples. Okay, so keep that in mind as we go to example A. Okay, so in example A, they're saying find the indicated measure. So in part A, arc length of AB. Okay, so they're being specific. They want you to find an arc length. So that means our answer is going to be some centimeter value. Okay, so in doing this, I'm going to use my formula. So I have my arc length. Again, if you want to, you could just call that x, right? As long as you understand what you're trying to find. Okay, so the arc length is going to be equal to 2 pi r times the measure of, and in this case, since I'm finding the arc length of AB, my measure that's going to go here is the measure of the arc angle AB over 360. So let's plug in what we know. We do know the radius, right? So obviously we know 2 pi r, but we know what r is. So I'm going to plug in for r, right? Remember the radius goes from the center to the outside of the circle. That makes 8b the value of r. All right, and then we're going to multiply that by the measure of AB. So if this central angle is 60, we learned up above that the measure of this minor arc would also be 60. So it's going to be 60 over 360. And now it's just a matter of using our calculator skills to get to our answer. I'm going to simplify this a little bit before I put it into the calculator. I know 2 times 8 is 16, and then I have pi. I know 60 over 360 actually reduces. If you wanted to reduce it by 60, you could. It reduces to 1/6, right? So you could punch this right into the calculator, all of that, or you can simplify it a little bit and then punch it into the calculator. Does not really matter because we are going to write our answer as just a decimal value. So this value of x, which you remember is our arc length, putting this into the calculator, I have pi times 16 times 1/6, or maybe you did 60 over 360, right? So if you want to times it by 1/6, and you get 8.377, so that's 8.4 or 8.38, however many decimals you want to go by. I'm going to do 2. I see it's centimeters, so that's going to be my final answer. Okay. In this next example, it's a little bit different because they are asking us for the measure of RS. Information from the picture that you can see from T to R. They give us a length of 15.28, so that means that that is our value of R. The other value that they have given us is they've actually given us the length from R to S. And notice it's not degrees, it's in units of measure like meters. So that means that this is an arc length. And this is a radius. So that's the information that we have. If you look at the formula, the part that we are going to be trying to find is we're going to be trying to find this value right here. Instead of AB, it's going to be RS, right? Okay, so the length of RS, right? If you're going to use arc length, RS, that means your measure of your arc and angle should also be with RS. So this arc and this arc right here, they should be the same. Okay, and they are. So the arc length of RS, in this case, it says it's 44. So that's going to equal 2 pi r, and I see my r, we already designated, is 15.28. And then we're going to multiply that by the fraction of the measure of RS, which we don't know what that is. So if you want to call x measure of RS x, you can, or you can write measure of RS and know that that is your variable. That's going to be divided by 360. Okay, so to solve this, what we're going to do is I need to get rid of all of this stuff that's being multiplied to this fraction with x. So I'm just going to divide it all. I'm going to divide all of it on one side with all of this on the other side. And this cancels, and this cancels, and then we will be left with some value here equal to x over 360. So let's figure out what that value is using our calculator, clear it out. I'm going to have to use my parentheses with my calculator because I have a lot going on down here. So I have 44 divided by parenthesis 2 times pi times 15.28, close the parenthesis, equals, and I get 0.458. And then the last step here, multiply both sides by 360. Cancel, cancel, leaving me with an x on the right-hand side. Remember, x is representing the measure of RS. Okay, so I'm going to go back to my calculator. I already have this decimal in there, so I'm just going to times this by 360. And you can see you get a measurement. Looks like it's going to round to 165. And it is degrees because remember the measure of RS is representing an angle measure. Okay, since it is 2 letters, it is a minor arc, which means your value should be less than 180 degrees. If you don't get something less than 180 degrees, you've done something wrong. And oftentimes it can be as simple as your calculator work. So you can always double check that. So if you like this video, hit like, and if you like all of my videos, please subscribe to my channel so you can easily find them. So good luck with your practice.